I'm going to go through an additional example problem. This is using the equal values method. It's just a variation of substitution. Sometimes people get confused when you have two problems that are set up like this one where you have the same variable isolated in both ones, but it's basically the same thing as substitution. You're still going to substitute an expression in for an equivalent variable. So I'm going to go ahead and walk you guys through a problem like that. So this is a relatively simple one. We have y equals 1/2 x plus 4, and we have y equals 3x minus 1. You'll notice that both expressions are equal to y. Therefore, I can say that 1/2 x plus 4 equals 3x minus 1. Once again, I can do that because they both equal y. Equal sign means they're equivalent. So what I'm going to do, I'm going to go ahead and take this top expression right here. I'm going to go ahead and circle it. Right? And then essentially what I'm going to do is take this expression and insert it into the second equation in place of y. Once again, I can do that because y is the same thing as 1/2 x plus 4. Now, when I solve a system, I generally break it down into 4 quadrants. First is a setup. The second quadrant is solving for the first variable. The third is solving for the second variable, and the fourth is check. You can do whatever technique you want. It's just the way I organize my work. So when I rewrite this equation, I'll have 1/2 x plus 4 equals 3x minus 1. So what I did is set those two expressions equal to each other. I'm just going to go ahead and solve. So I'm going to subtract 1/2 x on both sides. And at the same time, I'm going to go ahead and add 1 to both sides. That way I can just, save some time, save some space. Okay, so this cancels out. I have 5 equals 3 minus 1/2 is 2.5x. I'm just going to go ahead and we'll go ahead and say 2.5x. All right, you could write that as 5/2 if you wanted to as well. That'd work. Either way is fine. And I'm just going to divide both sides by 2.5. Okay, 2.5 goes into 5 twice. So 2 equals x, or x equals 2. Okay, so that's my first variable. Now I'm going to do the same thing that I would do with any kind of systems problem. I'm going to go ahead and plug the value x equals 2 into one of the equations and solve for y. So let's go ahead and do that. I'm going to go ahead and use the top equation. So I have y equals 1/2. I know my value of x is 2, so I'm going to replace x with 2 plus 4. Okay. Half of 2 is 1. 1 plus 4 is 5. Y equals 5. Okay, now I know my ordered pair should be 2, 5. So that's where I think the line y equals 1/2 x plus 4 and y equals 3x minus 1, I think that's where those two lines cross or intercept. So now I'm going to check. So last step here is verify that my answer of 5, 2 is correct. So I'm going to go ahead and put in 5 for y. 5 equals 1/2 times 2 plus 4, question mark. I'm trying to verify it. That's why the question mark's there. 5 equals half of 2 is 1. 1 plus 4 is 5. 5 equals 5. So it works for the second equation. I'm going to do the same thing for the second equation. So y equals 3x minus 1. Put 5 in for the y, 2 in for the x. That's 3 times 2 minus 1. Little question mark because I'm trying to verify something. 5 equals 3 times 2 is 6. 5 equals 5. It works for both. Therefore, the solution to my system is 2, 5. Okay, so remember, equal values method, all you're doing is setting the expressions that are equal to the isolated variable equal to each other. That's what I did right down here. Then you solve for your first variable, use that answer to solve for your second variable, and then when you're done, you go ahead and use your ordered pair, your coordinate, your point, whatever you want to call it. Plug it back into the original equations and make sure it works. In this case, it does. All right, hopefully that will help you guys with your question. Thanks.